Fraser Nation, once again, about to round out triangle congruence. We have another section today, 4.5. We're going to prove triangles congruence by angle, side angle, and angle, angle, side. These are the last two congruence theorem methods that we're going to use. We've had side, side, side. We've had side, angle, side. We've had hypotenuse, leg. And now finally we're going to have angle, side, angle, and angle, angle, side. Students will be able to prove triangles congruence using various methods. There are 5 in all. There are 5 total. So make sure that you know all 5 of these. Probably use Quizlet to quiz yourself. I want you to remember a few things. Included, when I use the word included, that means in between. So if I have, say, for example, a triangle like this right here, and I know this angle, and I know this angle, then this right here is the included side. Okay? That's the included side because it's in between the two angles. So included side between the angles. Okay. Let's see. Side, side, side. SSS. Okay. That means you'd have to prove all 3 sides congruent. Side, angle, side means obviously SAS. You have to prove 2 sides in one of the angles, and the angle must be in between. It must be included, okay, between your 2 congruent sides. Hypotenuse leg is HL. This only works for right angles. And remember, the hypotenuse is always across from your right angle. So this is the hypotenuse. And then you have to prove one of the legs. It's not HLL, it's just HL. Okay? And then vertical angles are congruent. So anytime I have 2 angles that are across from one another, the angles are going to be congruent. So the top and the bottom one are congruent. Let's go ahead and see if we can't color code that. I should have color coded it. So the top and the bottom are going to be congruent. Okay, so if this was 40, 140, this would have to be 140. Okay, and then these 2 angles will have to be congruent. So if this was 40, then this would have to be 40. Okay, so it's angles that are across from one another. Let's move on. Postulate 21, angle, side, angle, congruence postulate. Number 1, I want you to notice the S is in the middle. The S has to be in the middle. The side has to be in between. So if 2 angles in the included side, okay, so I'm going to write this again, in between. So if the in-between side is between your 2 angles, are congruent to 2 angles in the included side of a second triangle, then the 2 triangles are congruent. The same size and same shape. Okay, so let's look at these 2 triangles. First and foremost, you need an angle, a pair of angles. So if angle A is congruent to angle X, if angle B is congruent to angle Y, and then the side in between, okay? So AB is in between these 2 angles, XY is in between these 2 angles, then your triangles ABC has to be congruent to XYZ, okay? It wouldn't make sense to say XY and AC because AC is not between these 2 angles, XZ is not between these 2 angles, so that just wouldn't work out. Next card. Theorem 4.6, angle, angle, side. Notice in this one, the side has to be outside your two angles. It cannot be in between, okay? You would use angle, side, angle for that. So if a non-included side, so not in between. So if your side is not in between two angles, but you can still prove two angles congruent. So if I have angle A and angle K, if those are congruent, if it tells me they're congruent, angle V and angle R are congruent, and then your side. Okay, so if DA and BK, or you could have used DV and BR, but let's put here cannot use sides AV and KR. Okay, you cannot use those because that will be in between your two angles. Then DAV is congruent to BKR. Okay, give you a second to write this down. All right, let's get some examples going. In the diagram, this diagram right here, what postulate of the theorem proves triangles RST is congruent to VUT? Well, what's given? Okay, what do they give you? They give you that angle S is congruent to angle U. Okay, we know that. And then we know that side RS is congruent to UV. Okay, and so what do we need to know? We can prove, okay, well, if we have this angle, we have this angle, that's done. Is there anything that we can do to prove angle R and angle V would be congruent? No, because we don't know that these lines are parallel. We can't use alternate interior angle. We can't use that. But if we can prove that RTS, okay, so angle RT, wow, I said it and wrote the S. Angle RTS is congruent to angle VTU. And why can we prove that? Okay, so why can we say that this angle is congruent to this angle? Because of vertical angles. Okay, remember I told you vertical angles are congruent. So vertical angles. Okay, we can prove that these two angles are congruent. Well, what do we have? Okay, we have angle, angle, side. Okay, so we can use angle, angle, side. And why is it not angle, side, angle? Why can we not use angle, side, angle? Why can we not use that? Because RS is not between these two angles. UV is not between these two angles, or these two angles. UT is not cannot be used. So we can use angle, angle, side because we have an angle, and a non-included side. Okay. Is it possible to prove these two triangles congruent? Explain. Well, we're given. Let's see. Angle RPQ is congruent to angle PRQ. We got that. So this angle is congruent to this angle. Given SPR is congruent to angle SRP. So we have these two angles, it's probably going to be a safe bet to use angle, side, angle, because look at the side in between. Okay, so we can prove what? Well, we can prove that PR is congruent to RP. And why is that? Well, anything is equal to itself, congruent to itself. So we can say reflexive. We can flex on them. We can flex on them. We can use the reflexive property. So if we use the reflexive property, we can say PR and RP are congruent. So we can use, or yes, it is possible. And we would use angle, side, angle, because we have an angle, the side, and the angle. The side is in between. Angle, side, angle. So we would say angle or triangle PQR is congruent to our triangle RSP. Okay. One last example. So we'll have some problems like this in homework. Given DE is congruent to AB. So in your homework, I know they give you this and you have to use the same triangle 3 times. It might be better for you to copy this on a piece of paper and then, do it for each one. So mark DE and AB. I want to use red. Let's use red. Okay. So given DE is congruent to AB, given angle E is congruent to angle B, okay? What can I use? What angle could I use to use angle, angle, side? Well, I cannot use angle D and angle A, okay? Because that would make my side in between and I would have angle, side, angle. So cannot use angle D and angle A, okay? I cannot use those. I cannot use these because that would make it angle, side, angle. What we want to use right here is angle F and angle C, okay? So if I use these 2 angles, then what would you have? You would have angle, angle, side, and then you would have angle, angle, side, if we're using the angle, side, angle, okay? So get to the homework. Unit test coming soon. And I've had a great time. You've had a great time. See you.